Hi, my name is Gianna Whitty, and I'm going to be presenting to you gene editing. What is gene editing, though? Gene editing is used with technology to make changes to one's DNA. It is used to treat and prevent human disease as well as change in physical traits of a child, such as hair and eye color. However, they still are testing and researching if it is possible to do this with older adults. These technologies act like scissors, cutting the DNA at a specific spot. Then scientists can remove, add, or replace the DNA where it was cut, sort of a breakage and repair of DNA. For example, if a mother and a father decide they would like to ensure their child has blue eyes because they both have blue eyes, gene editing can be used to change this physical feature. I do have a 3-minute video that I wanted to share with you, but since I cannot add it into this, I am going to put the URL in the link below or add it at the end of the video. The term CRISP is a family of DNA sequences found in the genomes of prokaryotic organisms such as bacteria and archaea. These sequences are derived from DNA fragments of bacteriophages and had previously infected the parasite they used to detect and destroy DNA from similar bacteriophages. Sorry, I'm butchering that. During subsequent infections, it has been 7 years since scientists first learned how to precisely and reliably splice the human genome into a tool called CRISP, making it possible about snipping out disease-causing mutations and actually cure once and for all gene diseases ranging from sickle cell anemia to certain types of cancer and even blindness. But what does CRISP have to do with chemistry? CRISPR are pieces of RNA and hold information carrying molecules. They can guide an enzyme called Cas9 to cut through genetic material. The two women, Jennifer Dunda and Emmanuel Charpentier, helped turn a bacterial defense into one of the most powerful tools in genetics. For their efforts, they have just received the 2020 Nobel Prize in Chemistry. I am going to read off a quote. So this was said for the Nobel Prize. The genetic scissors were discovered just 8 years ago, points out to Pernilla Winning Staffshed. She's a member of the Nobel Committee for Chemistry. Already, she notes, these fantastic scissors can cut DNA where you want. In doing so, they have revolutionized the life sciences, she says. We can now easily edit genomes as desired, something that before was hard or even impossible. It is used to guide molecules to find a specific region in an organism's genetic code. A mutated gene, for example, which is then cut by enzyme Cas9 when the cell tries to fix the damage and effectively disable the gene. This in itself is useful for turning off harmful genes. There are thousands of genetic disorders that can be passed on from one generation to the next. Many are serious, and debatingly, they are not rare. 1 in 25 children is born with a genetic disease. Among the most common are cystic fibrosis, sickle cell anemia, and muscular dystrophy. Gene editing holds a promise of treating these disorders by rewriting the corrupt DNA in patient cells. Gene editing has already been used to modify people's immune cells to fight cancer or be resistant to HIV infection. It could also be used to fix defective genes in human embryos and so prevent babies from inheriting serious diseases. This is controversial because the genetic changes would affect their sperm or egg cells, meaning the genetic edits and any bad side effects would be passed on to future generations. When speaking about breaking DNA at a specific location, before CRISPR, 2 different approaches were used to make site-specific double-stranded breaks in DNA. One based on zinc finger nucleases, ZFNs, and the other based on transcription activator like effector nucleases, TALENs. ZFNs are fusion proteins composed of DNA binding domains that recognize and bind to specific 3 to 4 base pair long sequences. And when talking about the pandemic that we're in, COVID-19, scientists have been researching CRISPR technology to see if it could help with rapid diagnostic tests for COVID-19. Research continues as such tests are now being developed for widespread clinical use in other areas. Scientists have looked to CRISPR as a potential therapeutic, utilizing its targeted enzymatic activity to destroy SARS-CoV-2 RNA and prevent viral replication. CRISPR has been well and truly deployed in the fight against COVID-19. Overall, gene editing can help to treat and prevent diseases by improving the safety, effectiveness, and efficiency of existing gene therapy techniques, now in use or in clinical trials. I believe this is something I would use if it was possible to treat adults, and that would be to remove the cancer cells that my grandma's continuously beat, but had always come back. Although she is a strong woman, this is not something that needs to continuously affect her life and can change the lives of many other individuals. Another use that I would put towards it would be my cousin. He suffers from HIV, and if it is possible to destroy this in his body just by genetic editing, I would love to be able to do that and help many other people. Overall, I think gene editing can make a huge impact on the world by preventing the diseases and improving the safety of individuals. I would love to see where this goes moving forward. Thank you.